Since the beginning of the year, we've been looking at how variables work. As you know, when I hear the word algebra, I automatically think that I am talking about something with a variable or variables. A variable is a letter that represents a number. An algebraic expression is a mathematical sentence. Algebraic expression is a mathematical sentence, we'll just say math, that has variables. For example, we've seen this already. This is 2x plus 3y. That's an algebraic expression. Actually, a plain old variable is an algebraic expression. And here's another algebraic expression. Just so you know, these two things are called the terms of the expression. And, as you also know, we've learned how to simplify this one already because we know how to get rid of the parentheses. This is 3x plus 12. And it's our first experience with a big idea that if it's true in algebra, if 3 times x plus 4 equals 3x plus 12, because no matter what I plug in for x, it will always be true. If I say 3 times 2 plus 4, whatever, I'm just calling x equaling 2, it is the same, no matter what number I plug in, it's the same as if I say 3 times 2 plus 12. This is 6 plus 12, and this is also 6 plus 12. So keep that in mind. I'm going to be saying it throughout the year. It's true if it's whatever we're talking about with variables is true in algebra if it works no matter what variable I plug in. Idea of arithmetic, how addition and multiplication relate. If I have the number 2, that's the same as saying 1 times 2. If I say 2 plus 2, that's the same as 2 times 2. If I say 2 plus 2 plus 2, that's the same as 3 times 2. This is true of all, no matter what I plug in. I mean, always, this is 4 times 2. Now let's look at the same idea with variables. Let's say I'm talking about x. I don't know what number that is, but it's a number that's represented by this variable. Oops, sorry for my sloppy x. Must go back. Okay, here's x. That means I have 1 times x, or 1x. If I say x plus x, just like with multiplication, with numbers, no matter what that number is, it's the same as saying 2 times x. If I say x plus x plus x, that's the same as saying 3 times x. And x plus x plus x plus x is the same as 4 times x. And this would be true if the number were 3. If it's 3, that means 1 times 3. 3 plus 3 is the same as 2 times 3. This one's 6, this one's 6. It works no matter what I plug in for it. Let's look for a minute at the term for x. We know that x is called a variable, and we know with algebra, when we're right next to each other, it means multiply, and the number always goes in front. That number has a special name. It's called a coefficient. And we're going to be using that term quite frequently. It tells how many there are, at least when we're talking about addition. Well, that's too hard to explain. Let's just say it tells how many. Okay? So let's look at the 2x plus 5x. This means I have two x's. I don't know what those x's are, but I have two of them. If I have 5 more of them, it stands to reason that I have 7 of them altogether. And I can check this in two different ways. First of all, I can just choose a number for x to represent. Let's say if x is 5. If it works, no matter what number I plug in, let's say 2 times 5 plus 5 times 5, does it equal 7 times 5? Is 10 plus 25 equal to 35? And the truth is yes, because this is always true. It wouldn't matter what number I plugged in, because 2x and 5x are called like terms. And that just means, here's a fancy way of saying it is, well, actually, here's a not so fancy way of saying it. If everything is the same except the coefficient, they're like terms. So if I erase the coefficients, are they exactly the same? Yes, they are. So they are like terms. When I have like terms, I can combine them by adding the coefficients. So my coefficient here is 2, my coefficient here is 5, so we simplified this by combining the like terms, saying 2 plus 5 is 7. That makes this equal to 7x. Let's do some like terms. Actually, so if that's true, sometimes kids think that 2x plus 5y is equal to something like 7xy. And we can tell by plugging in different numbers for x and y. Let's say x is 2 and y is 3. We can right away say, does 2 times 2 plus 5 times 3, see I'm plugging in 2 for x and 3 for y, equal 7 times 2 times 3. Well, this is 4, and this is 15, which is 19, and that does not equal 42. Okay? The reason why this doesn't work is because 2x and 5y are not like terms. And this is very important. You cannot combine unlike terms. I'm going to trick you on a test, and I'm going to ask you to simplify, and I'm going to give you something like this. And you have to say, you can't combine unlike terms. It is already simplified. You can't do anything more than that. In fact, if you do something more than that, it's really a problem. It's quite wrong. Like terms. If I say 2x plus 3x, we already know that that's exactly the same when I take away the coefficients. So 2x plus 3x, now I can combine by adding my coefficients. That's 5x. 2x plus 3y, however, if I take away the coefficients, those are different. So they are unlike terms, already simplified. Here's one that's confusing to some kids. If I say 2x plus 3x squared, are those like terms? Well, in my very scientific take away the coefficients, are those the same number? No. If I say if x is 3, then this is 3, and 3 squared is 9, so they are not like terms. So how does this apply? What do we have to do here? Some steps for simplifying algebraic expressions. Okay, and we're really putting together a couple of things here. The first thing is if there are parentheses, you get rid of parentheses, and I don't just mean you erase them. you need to use the distributive property, which nobody had many questions on today, so I assume you get it. Then you have to combine like terms. Sorry if it's so sloppy. By the way, if I say 2x plus 5 plus 6, numbers aren't variables, they're actually called constants. And they are like terms. So in order to simplify this, I'd have to call it 2x plus 11. So this is if I say 2x plus 8 plus 3y plus 4 plus, I don't know, 3x plus 5y. All right, this is a one-step problem because no parentheses, I go straight to combining like terms. And if I have more than one variable, the convention is to put them in alphabetical order. So I'm going to look at my x's first. And notice when I box this, I'm including the sign in front of it. That will help you when we get to negative numbers as well. 2x and 5x, when I combine those, I get 2x plus 3x, excuse me, gives me 5x. Now I'm going to look at my y's. 3y plus 5y is 8y. Now I'm going to look at my constants. 8 plus 4 is 12. Can I do anything more? No! These are unlike terms. These are the kinds of problems on your homework where you're allowed to do them on the sheet because they're one-step problems. Unlike something that looks like this. I don't know. Okay, on this problem, I have to first do the distributive property. I have to distribute the 2 over the x and the 5, and that gives me 2x plus 10, and then I just bring down the stuff that wasn't affected. So that's my first step, the distributive property. On my second step, I combine the like terms. And as you can see, there's 2x and 4x, which gives me 6x plus 13. In order to do this properly, you must show each step separately.